Step outside on a clear night and look up at the sky. You'll see stars scattered across the darkness like tiny sparks in an endless ocean. But here's the strange part. The universe contains hundreds of billions of galaxies, and each galaxy holds billions or even trillions of stars. That means the cosmos is filled with unimaginable amounts of light. So here's the mystery. If stars shine in every direction across an enormous universe, why isn't the entire night sky blazing with light? Why do we see darkness at all? This question puzzled astronomers for centuries. It became one of the most famous cosmic riddles ever asked, a mystery known as Olbers' paradox. And surprisingly, the answer reveals something extraordinary. The darkness of the night sky is not just a lack of light. It is evidence of the history of the universe itself. In this video, we're going to travel from the smallest particles of light all the way to the birth of the cosmos, to uncover why the sky above us is dark and what that darkness reveals about the universe. The guide invites the viewer to step outside on a quiet night and look up. Above the horizon stretches a sky scattered with stars, faint yet mesmerizing. Each tiny point is a sun, often far larger than our own. And yet, strangely, the universe above appears mostly dark. Now pause for a moment and think about what that means. The universe contains hundreds of billions of galaxies. Each galaxy holds billions or even trillions of stars. With so many cosmic furnaces burning, the sky should be blazing. Imagine standing in a vast forest where every tree glows like a lantern. No matter where you look, light would surround you. Every direction would eventually end on a shining trunk. In theory, the universe should behave in the same way. But when night falls on Earth, something unexpected happens. Instead of a sky filled with blinding light, we see deep black space. The stars sparkle quietly against an ocean of darkness. It feels almost peaceful, but also deeply mysterious. So here's the cosmic puzzle that has fascinated scientists for centuries. If the universe is packed with stars in every direction, why isn't the entire sky glowing like the surface of the sun? To understand that mystery, we must first look carefully at what we actually observe. The guide now invites the viewer to look up at the night sky again, but this time with a more curious eye. Yes, stars are scattered across the heavens, glittering like distant diamonds. But between those bright points stretches an enormous canvas of darkness. Most of the sky appears completely black. Even in places far from city lights, where the sky reveals thousands of stars, the darkness remains dominant. The glowing points never fill the entire sky. Instead, they appear separated by vast, empty-looking regions. It's almost as if the universe forgot to turn the lights on in most directions. Early astronomers noticed this strange imbalance long before modern telescopes existed. If stars are spread throughout the universe, logic suggests that every line of sight should eventually meet one, just like standing in a dense forest where every direction leads to a tree trunk. Yet the sky stubbornly refuses to behave that way. So scientists began asking a deeper question. Is the darkness real emptiness, or simply a sign that something else is happening across cosmic distances? Perhaps the universe isn't arranged the way our intuition expects. And to unravel that mystery, we must zoom in to something far smaller than stars themselves. The answer begins with the smallest messengers of light in the universe. Tiny travelers that leave the hearts of stars and race across space for billions of years. To understand the darkness above us, we must first understand these travelers. And that means exploring the very nature of light itself, to unravel the mystery of the dark sky. The guide now zooms in to the tiniest scale imaginable. Inside every star, deep within its blazing core, atoms are colliding under enormous pressure. Hydrogen atoms squeeze together so tightly that they fuse into helium. In that violent union, energy bursts free in the form of light. These packets of light are called photons. They're incredibly small, massless travelers born in the fiery heart of stars. Once created, a photon begins a long journey across the universe. It moves at the fastest speed nature allows, the speed of light. Think of photons like cosmic messengers racing through space. The moment a star shines, billions of them shoot outward in every direction. Some may wander through space for millions or even billions of years. A lucky few eventually arrive at a tiny blue planet called Earth. When those photons reach our eyes, they create the sparkle of the night sky. Each star we see is really a stream of ancient light finally arriving. Some of those photons began their journey before humans even existed. Others left their stars before Earth had oceans. But here's the intriguing part. If stars constantly release these endless rivers of photons, then space should be flooded with light in every direction. So why do so many regions of the sky remain dark? To answer that, the guide shifts the perspective once again. Instead of focusing on distant stars, we now look closer to home, right here on our own rotating planet, because Earth itself plays a surprising role in what we see when night falls. The guide now brings the viewer back to a familiar place, Earth. Our planet spins slowly through space like a giant cosmic top. One side faces the sun and becomes flooded with brilliant light. The other side turns away and slips quietly into night. During the day, sunlight overwhelms everything around us. The sun pours an enormous river of photons onto Earth. The sky glows blue, landscapes shine brightly, and shadows appear everywhere. It's like standing under a powerful cosmic spotlight. But as Earth rotates, something dramatic happens. Our part of the planet gradually turns away from the sun's beam. The flood of nearby photons disappears almost instantly, and suddenly, the universe reveals a darker side. At night, the only light reaching our eyes comes from faraway stars. These stars are unimaginably distant compared to our sun. Their photons arrive weak and sparse, like faint sparks drifting across a vast ocean. The result is a sky where light appears scattered and delicate. It's a bit like standing on a beach at night. A distant lighthouse may blink across the water, but between those flashes stretches a sea of darkness. The stars behave in a similar way across the cosmic ocean. Yet this explanation raises a deeper puzzle. Even if stars are far away, the universe contains an unimaginable number of them. Given enough distance, every direction should still end on a star somewhere. So why doesn't their combined light fill the sky completely? To solve that puzzle, astronomers had to develop tools capable of measuring the faintest glimmers in the cosmos. They began collecting tiny streams of ancient photons. And through those delicate measurements, a deeper story about the universe slowly emerged. To investigate the faint glow of the universe, astronomers built instruments designed to capture even the weakest light. Telescopes act like giant cosmic eyes, gathering photons that would otherwise slip past unnoticed. Instead of relying on human vision alone, scientists use sensitive detectors that can measure incredibly tiny signals. Even a handful of ancient photons can reveal astonishing secrets about the cosmos. When a telescope points toward a distant star or galaxy, it collects light that has traveled unimaginable distances. Some of that light may have spent billions of years crossing the universe. By the time it reaches Earth, it carries a story written across time itself. Astronomers simply have to learn how to read it. Think of it like catching messages in bottles drifting across an endless ocean. Each photon is a tiny messenger sent long ago by a distant star. By studying its color, brightness, and motion, scientists can reconstruct where it came from. Suddenly, a faint spark in the sky becomes a map of the universe. Using these techniques, astronomers can measure the distances to galaxies. They can estimate the ages of stars and track how the universe changes over time. Telescopes transform faint dots of light into evidence about cosmic history. Every observation becomes another clue in a much larger puzzle. But the more scientists measured the light of the universe, the stranger the puzzle became. Even when accounting for distant stars and galaxies, something still didn't add up. If the universe truly contained endless stars spread across infinite space, the sky should still glow brightly. Yet the darkness stubbornly remained. That contradiction forced scientists to confront a powerful idea. Maybe our assumptions about the universe were wrong. Perhaps space isn't infinite, eternal, and unchanging after all. And exploring that possibility leads directly to one of the most famous puzzles in cosmology. The guide now introduces one of the most intriguing puzzles in astronomy. Imagine the universe as an endless forest filled with glowing trees. No matter which direction you look, eventually your line of sight should land on a tree trunk. If that were true, the entire horizon would glow with light. Apply that same idea to the universe. If space stretches infinitely in every direction, and stars fill it evenly, then every line of sight from Earth should eventually hit the surface of a star. The sky should shine as brightly as a giant wall of starlight. Picture standing in the middle of an endless city at night. If every building had its windows lit, the skyline would blaze in every direction. The distance wouldn't matter, because there would always be another glowing window behind the last one. Light would stack endlessly across the horizon. But the night sky clearly refuses to behave like that. Instead of a blazing dome of light, we see scattered stars separated by deep darkness. The universe, it seems, is not behaving like that endless glowing forest. Something about our assumptions must be wrong. This contradiction became known as Olbers' paradox, named after the astronomer who famously discussed it. It challenges three simple assumptions about the universe. Perhaps space is not infinite, or perhaps stars have not existed forever, or maybe the universe itself changes over time. To solve the paradox, scientists had to think about how stars are born and how they evolve. Because if stars haven't been shining forever, that changes everything. Some regions of space might simply not have had enough time to light up yet, and that idea leads us directly into the story of stellar birth. The guide now shifts the viewer's gaze toward the life stories of stars themselves. Stars are not eternal lamps hanging in the sky. They are born, they evolve, and eventually they fade away. Each one has a beginning somewhere in the dark clouds of space. Deep inside enormous clouds of gas and dust, gravity begins a quiet process. Imagine a swirling storm slowly pulling material toward its center. Over time, the cloud collapses inward, growing hotter and denser. At its core, a newborn star ignites. This process happened about 4.6 billion years ago in our own corner of the galaxy. A collapsing cloud formed a young star that would become our sun. Around it, leftover gas and dust spun like a giant cosmic whirlpool. From that spinning disk, the planets, including Earth, gradually formed. It's a bit like watching a figure skater pull their arms inward while spinning. As material gathers toward the center, rotation becomes faster and more organized. The swirling disk flattens, and clumps begin forming into planets. What began as chaos slowly becomes a structured solar system. The important lesson here is that stars take time to form. They don't appear everywhere in the universe all at once. Entire regions of space can remain dark for millions or billions of years. Only when gravity gathers enough material does a new star ignite. And this realization begins to reshape the paradox of the dark sky. If stars have not existed forever, then many parts of the universe may still be waiting for their light. Some photons simply haven't had time to reach us yet. But the consequences of that idea go far beyond astronomy. The guide now invites the viewer to consider what the darkness of the night sky reveals about our own existence. If the universe has not been shining forever, it must have a history. Stars had to form gradually, lighting up the cosmos step by step. And that slow unfolding of cosmic time made everything else possible. Inside stars, nuclear fusion acts like a cosmic furnace. Hydrogen atoms fuse together and create heavier elements such as carbon and oxygen. Over billions of years, stars manufacture the raw ingredients for planets and life. Without those stellar factories, the universe would be made of almost nothing but hydrogen. When massive stars reach the end of their lives, something dramatic happens. They explode as supernovae, scattering newly forged elements across space. Those materials drift through galaxies like cosmic seeds. Eventually, they become part of new stars, new planets, and new worlds. Our own planet is built from that ancient stellar debris, the iron in Earth's core, the oxygen in the atmosphere, even the calcium in our bones. All of it was forged inside stars that lived long before our sun existed. In a very real sense, life on Earth is made from recycled starlight. The darkness of the night sky quietly tells us that this process took time. The universe needed billions of years to create complexity. Stars had to live and die before planets like Earth could appear. Cosmic darkness is actually a sign that the universe is still evolving. But our story doesn't stop with individual stars. Those stars gather together in enormous cosmic cities, each one containing billions of suns moving through space together. To truly understand the darkness above us, we must zoom out even further, to the scale of galaxies. The guide now invites the viewer to zoom far beyond our solar system. Our sun is just one star among hundreds of billions inside a vast spiral galaxy. This enormous structure is called the Milky Way. From the inside, it appears as a faint glowing band stretching across the night sky. Within the Milky Way, stars gather into spiral arms that slowly rotate around the galactic center. Imagine a gigantic cosmic hurricane made not of clouds, but of stars. Each star follows its own orbit, circling the galaxy over millions of years. Yet even inside this massive structure, the distances between stars remain enormous. If the Milky Way were shrunk down to the size of a continent, our solar system would be smaller than a grain of sand. The nearest star would still be hundreds of kilometers away. Space inside galaxies is far emptier than most people imagine. Now expand the view even further. The Milky Way itself is only one galaxy among trillions scattered across the cosmos. Between these galaxies lie unimaginably vast distances. Entire regions of space stretch for millions of light years with almost nothing in them. Light from those distant galaxies must travel extraordinary distances before reaching us. Even moving at the speed of light, the journey can take billions of years. Some of that light is still on its way right now. It simply hasn't had enough time to arrive. This realization hints at something profound about the universe itself. Perhaps the darkness we see isn't empty space at all. Maybe it represents regions of the cosmos whose light is still traveling toward us. To understand why, we must travel back to the very beginning of everything. The guide now invites the viewer to imagine traveling backward through cosmic history. Galaxies drift apart, stars grow younger, and the universe itself begins to shrink. If we rewind the cosmic clock far enough, everything becomes denser and hotter. Eventually, all of space leads back to a single beginning. Modern cosmology tells us that the universe began about 13.8 billion years ago. This moment is known as the Big Bang. It wasn't an explosion in space, but the rapid expansion of space itself. From that beginning, the universe started growing larger every moment. In the early universe, there were no stars, no planets, and no galaxies. The cosmos was a hot sea of particles and radiation. Over time, gravity slowly gathered matter together. The first stars eventually ignited, lighting up the darkness for the first time. But here's the crucial detail that solves the mystery of the dark sky. Light travels at a finite speed, about 300,000 kilometers per second. Even though that's incredibly fast, it still takes time to cross the universe. And the universe simply hasn't existed forever. Because the cosmos has a finite age, we can only see a limited region of space. Astronomers call this the observable universe. Beyond that boundary, there may be countless galaxies whose light hasn't reached us yet. Those regions remain hidden in darkness. So the night sky is not dark because the universe lacks stars. It is dark because the universe has a beginning. The photons from the most distant regions are still traveling toward us, and some may take billions of years more before they arrive. The guide now returns the viewer to the quiet stillness of the night sky. At first glance, the darkness above seems like emptiness, but the deeper we look, the more that darkness begins to tell a story. It is not the absence of light, it is the footprint of cosmic time. Every dark patch in the sky represents distance. Some regions of space are simply too far away for their light to reach us yet. It's like hearing distant thunder long after lightning flashes on the horizon. The universe is still sending its signals across unimaginable distances. In a sense, the night sky is a time machine. When we look up, we are not just seeing space, we are seeing history. Each star is a message from the past. Some began their journey millions or billions of years ago. Even the darkness itself carries meaning. It reminds us that the universe is not static or eternal. It has a beginning, an evolution, and a future still unfolding. The cosmos is still in the process of revealing itself, and perhaps that is the most beautiful part of the mystery. The sky is not fully illuminated because the story of the universe is still being written. New light is traveling toward us at this very moment. Some of it will arrive long after humanity is gone. So when we look up into the dark night sky, we are not staring into emptiness at all. We are looking into a vast cosmic journey still in progress. And somewhere in that darkness, the next chapter of the universe is already on its way.